Hello friends, today I will demonstrate you the WHO olfactometer, which can be used for both to study the repellence effect of an insecticide or repellence effect of any chemical that you wanted to test, as well as to understand the attractive power of any individual or any scent or any chemicals. The setup that I'm going to show you here that can be used for both purposes. It can generate the both vacuum as well as the compressed air can be sent to the system. So now I'm going to explain you the how the olfactometer whole setup looks like and what stage, how many stages it's been divided, and how this can be used for both for the repellence effect studies as well as the attraction studies. Now I'm going to show you actually how an install two-way olfactometer looks like. The two-way olfactometer looks like this. I'm going to identify here the components as well as the number of stages that olfactometer can be divided. The olfactometer can be divided into three stages. This is roughly we've been divided so that you'll able to understand what we mean actually by. The stage one is actually the mosquito release area. So here we release the insects. The stage two is the selections. This is the selection chamber. The released insects actually go into the actually the selection area. So after that, the air delivery system. So the air delivery system is the one that sends the air into the selection chamber, so that the air that is coming with all the chemicals or semi-chemicals or any other kind of scents that we wanted to test, so that we can see whether that mosquitoes are attracted or repelled. That selection can be done here. The air delivery system is here, so that I'm going to show you here. So this is actually the part one, stage one and stage two, where mosquitoes been released, the selection can be done. But the third part that I'm going to show you here, the third part is not drawn here. The third part is I'm going to show here. So if you see here, this is the one that I talked about, like mosquitoes will be released here, then they can be hold here for some time. Once you rotate the window, the mosquitoes will enter into the selection chamber. From this selection chamber, the mosquitoes will be either go from here to here or here to here. This is where actually the selection happen. This is the two-way selection olfactometer. So in order to the selection has to be done, we need to send actually the scented air either from this as well as to this. So the air delivery system is this. So you see here the air control valves as well as the air control generator. The air control generator here, it's as I said here, you can do both. Air delivery system can be both vacuum based as well as air compression based. Compression as well as vacuum based. So the vacuum based will be here in this area. This is the one that this unit can be attached with the electronic unit, so that you can control the blower speed of how the air is being generated. I'm going to discuss these parts in detail. But I'm just as initial step to start, I'm explaining complete parts what you may have received, and then how you need to look at the olfactometer. This is actually the compressor. The compressed air can be sent to the system. If you want to use the vacuum based, so you can use using this particular the air delivery system. Now I'm going to explain you the general concept, how the olfactometer has to work. Okay, so the olfactometer has to work by, so in order olfactometer has to work, now air to be sent into the system. In order air to be sent into the system, this can be done two ways. Either you use the compressor, so compress the air and then send through the olfaction selection system, or you can generate the vacuum. Like if you are sending the air, if you are compressing the air, you are actually sending the air by compressing here into the system. If you want the vacuum pump to be used, the air actually need to be sucked through the motor, the pump. This I'm going to explain. So you just need to remember here is that the air delivery system can be two type. One is compression based, another one is vacuum based. The compressed air or vacuum pressed air need to be cleared from scents that are present in the air. So the room air may have a different kinds of scents. Like, if you are working in a lab, there may be already people may be walking, maybe people may be there. They may be using certain scents on their body, or body odor may be also a scent. Body odor also is a scent. As well as the room itself, because of presence of due to different kinds of paints or different kinds of instruments or many other things actually releases a lot of volatile compounds, VOCs, into the air. So that air we cannot directly use in the olfaction system. So we have to clear the air from all kinds of VOCs, volatile compounds. So how can we clear this? This by sending the air in through the activated charcoal. So we have provided a chamber here. So the chamber looks like this. This is the, I'm just, it's not exact picture how it looks like, but I'm just sending, I'm just giving, my intention is to give you a picture, like, so how that looks like from this. Yes. So this is actually the inlet. This is the outlet. Inlet. The compressed air, the air that is compressed here, that will send through the inlet. The long neck, 7-shaped, long reverse 7-shaped leg, we have to use as inlet. You need to send air through this inlet. The air will go. We are keeping here the charcoal. So you have to see that, the charcoal is half filled at least. Half filled through the glass jar. So once the air is sent here, the air will get released and it try to escape from the chamber. So once the air is sufficiently filled, the air is escaping from here, from the outlet. So the cleared air, now we are sending to the humidifier unit. Why we want to send the air to the humidifier unit? It's because as you know that the insects cannot regulate their own body moisture. They tend to behave erratically when humidity is not optimally being maintained. So in order to maintain the air RH, we are sending the clean air through the laboratory water. So this is actually the RH. We are sending the cleared air through the same. This is again, we are going to provide you a similar kind of system. Like we will see. Now I'm trying to draw the most. So if you see like this, so this is the inlet, this is outlet. The inlet, the glass pipe is touched to the bottom, just like you see that it almost touches the bottom. There is a gap actually here. It may be around 3 to 5 gap will be there from the bottom, so that whatever the inlet we are giving, either the compressed air or the clear air, that is actually tend to escape. The air will actually let this gap fill this chamber, so that if it is filled with the charcoal, then air they will get purified. If the chamber filled with water, the inlet air picks up the water, some kind of moisture, and then the moistened air, like the RH, the moistened air will be come as outlet here. Outlet. So moistened air is almost like 90% RH. So you will see, like if you are giving any inlet air that has like a 20 to 30 RH, or maybe 40 to 50, it can saturate up to the 90%, 90 to 95% RH. So what we have done here so far, so the air is being sucked into the system through the pump, and then we release that air into the charcoal chamber. From the charcoal chamber, the purified air is again sent to the humidifying unit. The humidifying unit actually humidifies the air. The humidified air is being sent out again into the different systems. Like, this is where the air is channeled or sectioned, channeling the air. Now the channeling means, like, the from here to here, the air is actually coming as a one way. From here, if you are looking for like a two-way, we need to divide the purified air into two ways, so that we can send into the two different arms that I have shown in here. One here, like this. If you are looking for four-way, then you have to add a connector like this connector, first connector. From here, this is act as an inlet. The air is divided into two parts. From here again, you have to put one more extender, so that the air will be again divided into two more parts. So 1, 2, 3, 4. So air is first divided into 1 and 2, and then from 1 you will have a two ways you can divide it, from the 2, 1 or 2, so that total 4 ways. So but we just restrict right now for only the two-way division, the two-way channeling of the air. So the outlet air, what is coming from here, we have provided, like, this kind of air divider, the glass air divider, you may see it. So the air we are sending here, inlet. So you just need to imagine like this. So air we are sending from here to inlet. So this is actually the outlet 1. This is outlet 2. From outlet 1 and outlet 2, now you see that the air is being compressed and then sent here. So it may have a different from the outer 1 and outer 2, you may have different level of air pressure, coming out pressure. Like, it may have like a 3 liters per minute. It may have 3.2 liters per minute, or maybe 3.5 liters per minute, something like that. This is how, why this can be varied is because you are using the different kinds of silicon connectors here and PFE tubings. When the length, or the bends or nicks, that can decide the total amount of air that is being, even though it has been sent here from here, like 6 liter per minute, while you see the output, you may have a different outputs from the both 0.1 and 0.2. So now you have to neutralize using the air controllers. So what will happen when you send the air through the controller is that you're going to set visually what is the amount of air that is coming from the outlet A versus outlet B will be exactly equals. It means that the air that is coming out from outlet A, say for example it was 3 liters per minute, and outlet 3 is 3.5 liters per minute. Once the air is sent into the controllers, the control unit looks like this. So the real picture the controller should look like this. This is the air controller. This is the air controller. You see the knob here, and if you see the back side, you see the inlet actually as the outlet. I'm going to show you here. So this is actually the theoretical setup that we are discussing. Once we go into the detailed live video that how to do the installations, we're going to show you again. We're going to discuss where we need to give the output, and then where you need to give the output, and how to use the knob to actually to turn, increase or decrease the the total amount of air that is going out from the port A as well as the port B. So now if you see that this is the side view of the air controller unit. So you see the knob here, you see the scaling here. Scale shows like 400 ml to 1 liter, 1 liter per minute, or 0.4 liter per minute. So this is the scale. and you see a small ball, guiding ball, floating ball is actually floating ball is actually a response when you turn either clockwise or anti-clockwise by letting the air or restricting the air. So the air outlet from here we will send. So you'll have here two knobs. I'm sorry, the two the connectors. So this is actually for inlet connector. This is outlet connector. The output from here we are going to connect into the inlet. So air is coming from here, the clean air is coming and then it is going into the air control unit. Now you're going to set either turning the knob clockwise and anti-clockwise. You see the markings here. Say for example you want the knob to be here, so you are sending this ball, floating ball here, and then you are stopping it. It means that the air what is coming here, while it is going out, it is being regulated. It is regulated at where? So at your desired level, maybe around 600 ml per minute. So this is the standard output that you have set it up for the outlet A, as well as you want to do like the same thing for the another outlet from here. So you're going to do the same thing here by sending to the air controller. You're going to set the ball at the center so that the air what is coming inside and is actually regulated to the level where we need it. Like earlier it was coming like 3 liters per minute as input, but then when we set it up, like if you wanted to have a 600 ml per minute, the output air will be exactly like a 600 ml per minute. So what we have done here, we took the air, divided then you done like cleaning up the air, making the moistening the air, and then you divided the air into two ways, and then the two-way air is again controlled here to the desired level. So from the desired level, then we are taking the air into the now this system here. So from here you are sending into the chamber A and chamber B. Chamber A and chamber B can be like you can actually use here say like any kind of control, and here maybe the test. Okay, now what to be controlled, what to be tested, and how you can use the hands or actually the human's hand, that I will discuss later. Let this to be finished, and then we will be going again to the second part, that the actual way how we can actually modulate the instrument. Okay, now you think that just imagine like we have put here the scent A and then here the scent B, scent or any kind of order, that anything that you imagine that you wanted to test. Yes, so now what is happening is that the controlled air through the air controllers we are sending into the selection chamber. So this is arm A, maybe arm B. So maybe arm A you are using as a control, or maybe this cannot be just a control or anything neutral. You can actually use like a two tests, like you already have a scent from X company, or maybe from X plant you wanted to test against Y plant, or maybe YX combination versus Y combination. You don't here you don't have to must be using control. There is no control concept here. It is versus, like either this or this. So that's how you need to do the comparison. Yes, you see here, this is the okay. So now the controlled air from here, this is the outlet. You are going to from this outlet will be connected into the inlet of this chamber A, arm A, and then from here you are going to connect into the arm B. So the air that is regulated here at the rate of 600 ml per minute is sending to the arm A as well as arm B. So now when this air fumes are getting mixed, so now you as we discussed here. So you have actually placed like the cotton laced with maybe volatile compound A or anything like chemical B here. So the air that is passing through the volatiles will picks up the scent what is being sent here, and again equally mixes here. It forms like it's a kind of a cloud, the mix of chemical cloud. Now the insects are released from here. So this is the insect release area. It's too far. Okay, I'll make it here. This is release area, release hole. This is the holding area. It means that once you release the insects, you want to let the insect get acclimatized to the environment of the glass chamber, like the any plastic chamber that whatever we are using here. You want to let the insects to be stay there for like maybe 5 minutes. You just wanted to let them like that, so that once insect get acclimatized, you're going to revolve this door. So you can revolve it. I'm going to show you how you can do the revolutions. So you see the knob here. Yeah, you can see here clearly the knob. Actually, you turn the knob, you can actually open this particular window like this, and then if you want to close it, you turn this way, it will be closes off. What you are doing here is that once you release the insects here, insects have been released here, insects released, you're going to hold them here for 10 to 15 minutes. Holding is how? By closing this door. You're not letting the insects actually go into the selection chamber yet. You wanted them to get acclimatized here. So once the insects get acclimatized here, you want to send them by turning clockwise, and you are opening the door, the insects actually to go into the selection chamber. So this is where the selection happen. Selection chamber. Here the fumes are there. The fumes are mixed here. So the insects are released here first, and this is like a revolving window. So the revolving window, you closed it now, and then after maybe 5 to 10 minutes of acclimatization of insects, you turn halfway so that insects will move into the selection chamber. In the selection chamber, say for example, this is you are looking for like a attractant or something like that. So obviously if insect would like to feed on this particular kind of a scent, obviously insect get more number of insects you see in this area, less number of insects you see in this one. So this is actually the general concept, the how the olfactometer that should be working. So this is the general concept. Now in part 2, I will explain you how to actually set up the original setup of the olfactometer. I mean the practical setup. First is we have theoretical understanding, and then we do the practical setup. In the practical setup, we will show you that what are the different kinds of parts you may have received and what is the importance of each part, and we will try to correlate with the theoretical understanding what we have done here, so that you will know that what part and how you have to use, how securely, or what is the value you have to give that particular part while the installing the olfactometer. And then third one is troubleshooting. Like few of the times you may have the doubt, like what happens if you're when to use the vacuum, when to use the compressor, how to clean it, how to take out the dead insects, and what are the certain difficulties, or how you need to seal the chamber. That all things we will discuss in the troubleshoot section. Okay, this is the part 1. So I will so once I'll ready the system, we'll make the part 2. Thank you. Okay, so before closing this part A theoretical understanding, I'm going to explain you in general that what we have seen here up until now. The compressed air is sent to the into the activated charcoal. From here, the purified air is being sent to the water to the laboratory water. So here you have to mind to use either double distilled water, preferably, or no RO water, please, because it still contains some kind of minerals. If you don't have double distilled, then you can go for RO, or else if you have a molecular biology lab, or if you can source milky water or type 1 water, you can very well get it, or you can buy. You can ask us to ship water. We can supply that for you. So the purified air, because why I'm saying this is that once you have purified air, the air you doesn't want the air to be picked up any other kind of the scent or any other kind of the dissolved organic matter, organic anything that might present in the water to be picked up by the air. Again, it might contaminate the experiment. That you doesn't want to do it. So once the air is humidified here, you are dividing the air into two ways. From A and 2, the output of from A and outlet B, that is being regulated here using the air controllers, so that once you send the air to the regulators, you can see visually, you can manipulate what amount of air that you wanted that let into the system. So the controlled air is again channeled into the chamber A, chamber B. So in the chamber A and the chamber B, you will be keeping actually scent A and scent B. This doesn't necessarily to be controlled versus anything. So you can use anything like 1 versus 2, or type A versus type B, or chemical plant A versus plant B. So now the controlled air is sent to the part A, the arm A, arm B, and then you will see here the cloud of air is being saturated in this area. The insects are they are holding here for 5 to 10 minutes, and then you open the revolving door. The air is trying to go out through the so this is outlet for the olfactometer, or this is the end of the olfactometer. You can think of the air is generated here. So through the air packed system, there is no leakages here, that you have to mind. There is no leakages here. Then there is only one leakage, that the air that is compressed here sent into the system. There is only one place that has to come out, is this. So the air is transported all through this way, and then air is going out from here. So while it is going out, it carrying these fumes, the insects actually travels against the fumes, and then they get selected here. Thank you.